Okay, so just to remind everyone, back again, 24th of Feb, we've got our mini prelim. The date, so make sure you keep that date in your diary. So if you are allowed to have extra time, then you would still need to contact ELS directly. The formal homework this week has been set up. Okay, so we expect high marks from you guys. So I'm going to give you today some feedback on trig graphs. And we looked at finishing trig graph, past paper question. And I'm just going to mention something about transformations. And just so that you know, some extra lessons on transformation will come live later on tonight so that you got a better idea, not just what I'm going to be talking to you today. So any questions so far? Mini prelim or exam, which is taking place, like I just mentioned, at Langside in May.
Are we in the class before the mini prelim? I can't remember if we agreed that or not.
So basically we'll be there at 17:30, so 5:30, so that we can start at 5:45.
Yeah, no, sorry, I meant like next week. Are we going to go into the
No, the revision session. So it's going to be online. So it's going to be online. So we looked at the formal homework, which should have a bit of everything, and we're just going to do the revision online. Okay.
No worries.
Any other questions before we move on? All right, so I just put there, well done by some, not done by enough, to be honest. Then I could have given you a bit more feedback. It's a poor show, to be honest. If I only get like 4 out of 24 people, when you think you can just go to Desmos and just type the function and it would give you exactly what it would look like. So at the end of the day, what we're trying to see at this level is not to be very, very precise. What you'll find during the nat5 type question, they'll ask you maybe to sketch a graph, which give you, an overview of the graph rather than being precise. And I'll show you how we can do that very quickly. So, but you need to get that practice in, because if you don't practice that, like some told me earlier on that even at nat5, they can't remember having practiced that. But I do see questions like that come in. Okay, so once you practice them, then you've got a better understanding of what type of question you're asked to find during a trig equation. Okay, so I'll go through the solutions, and then if you've not submitted yours, you can still give it a try. Okay, so the key features to remember when we come to looking at trig graphs, key features is, first of all, you need to be able to figure out what the shape is. Let me grab a pen. So the shape is a key feature of your graph, what it should look like. Then the other thing that you have to do is you need to be labeling. So you need to have labeled axes. That's usually X and Y. And then I'm going to mention what we call the key features, so that you've got a better understanding of what we're trying to do. So sine waves are something that we use quite a lot, especially if you do any work in things like, if you do like engineering type work, or if you do physics, you would use like signal generators, and most of them would bring you a sine wave. And if you ask me what is the most common sine wave, then you can just say a sine wave is like a sound that you hear, and a sound that we hear is made of a certain frequency that our eardrum would receive and translate into a sound that is projected into our brain so that we get the sound, okay? So if I'm asked to draw y equals sine x, first of all, I put my y and my x axis. So by default, it's the standard of using y as your vertical and x your horizontal axis, okay? The next thing is sine wave. The thing that I know about sine wave, I know that it starts at 0, 0. Because if you do sine 0 degree in your calculator, you would get 0. Okay, so straight away, I would know that it starts at 0, 0. And the sine wave is just a wave that goes up and down and back. So as you can see, I'm using a tablet, so it's not that accurate, but this is what a sine wave would look like. And the amplitude of a sine wave, which is just y equals sine x, would go to +1, and it would go down to a maximum of minimum of -1. So that's your amplitude given. And you've got your wave started at 0. Because it repeats itself after 360 degrees, then a key feature would be 360 here, and half of the sine wave is at 180. So think about a full circle, and from your full circle, you go up, then pass by 180, down and back up again. So between 0 and 180, you've got what we call a turning point, a maximum turning point that happen at 90 degrees. And again, between 180 and 360, you've got another minimum turning point, which is at 270. Okay, so x is in degree C. That's why your axis start at 0, then goes to 90, 180, 270, 360, max +1, min -1. So the roots, if someone asks me, what are the roots? They're asking me, what are the x-intercept? So we intercept at 0, 0. So 0 in x, 0 in y, 180, 0. And the last one, 360, 0. So those are my roots. And my max is at 90, +1. And the min, 270, -1. So basically that's us. We've just drawn a sine x wave. The thing to remember as well, always good to label what we've just done. So this is y equals sine x. Okay. So any question on that? So that took maybe 5 minutes.
Adrian,
Yeah.
it's not a question, but when I was doing this with my tutor, I was like, why is it always like the number first, like the bigger number first? Just because I was writing it down the wrong way, and I was like, why can't I remember that? But like, I don't know if it's a good tip, but the way I remember it now is like, it was like, think about like a plane, they always need to go along before they can go high first. So that's now why, like, I remember always put like the big number first. Does that make sense? Because I kept on getting it down the wrong way all the time.
So you were going down first and then back up?
So like I would be always putting like 0, 180, and he was like, that doesn't make sense. Think about like a plane, for example, they can't just go high, they need to go along before they can go high. Does that make sense?
Yeah, yeah. Yeah,
if that helped anyone, because that's what helped me, and I was like, I'm keeping getting this wrong. But I just thought that was handy.
So do you go from 0 to 180 and then down up to 360, yeah?
It's just because I was writing like 0 first all the time, but rather, or like I was always writing like 0, 180 or like 1, 90. Like I was always writing a smaller number first.
Ah, okay, I see what you mean. So basically, you just have to remember you've got your x-axis and your coordinate are always x and y. I think if you do that as well, then you'll know that on x, I've got 180 when y equals 0, and then x 360 when y equals 0. So as long as you look what you've got on x and then what you have on y, and if you can remember that, that should be okay. Okay. So now I've given you y equal sine x. If someone asks you, draw y equal, I don't know, 5 sine x this time, 5 times sine x, I would do exactly the same thing to draw this. I would put my y-axis and an x-axis. I would just draw the exact same where you have your roots there, 180, 0, and 360. The only difference between my y equals sine x and my y equal 5 sine x, when I had sine x equal 1 at 90, because I time it by 5, now my maximum becomes 5. And the same for my minimum would become -5. So if someone asks me, draw 5 sine x, this is exactly the way I would draw it. I would put the 90 again here and the 270 here. And I would remember x here, y there for my axis. And you can label it if you want. This graph is y equal 5 sine x. Okay, and if you were to take your calculator, you could check that when x is equal to 90, 5 sine x would give you 5. Okay, and that's what I meant by it's a sketch you're asked to do. It's not a Picasso art. Okay, so any question on that sign? Because then we can move on to doing cosine now. All right, quite happy? You've got an idea what we need to remember? Amplitude, roots, and the general shape. All right, so let's do now the same thing, but for cosine. I'm going to need more space now. So what I've found with cosine is cosine, first of all, cosine stands for the complement of sine. What do I mean by the complement of sine? So cosine, when someone tells you cos of x, what they mean is the complement of sine x. That's what it stands for. Which means if you can draw sine x, you should be able to draw cosine x. Okay. If you remember, or maybe you might not remember, what do we call complementary angles? What are complementary angles?
90-degree angles.
Yeah, so if you add them, complementary angles add up to 90, right? Complementary angle add up to 90 degree. Which mean, because they add up to 90 degree, to find cosine, you can just slide the y-axis by 90 degrees. Okay, so if you were to just slide by 90 degrees, your y-axis here. So imagine, oops. Can you still see what I'm sharing, or is that gone? Let me share again. Looks like my share screen is gone. Which means just imagine if the 0 had moved to the 90 here. So you would technically have something that would look like a bit like my cosine would start here with a 0 degree here. So you just take that, but to finish it at 360, you just need to add that same shape. And that's why my cosine is just this shape going down. I would need to do it a bit better than that. Hold on, I'll start again. This is what happens when you've got a tablet. So my cosine basically is just this shape and finishing there at 360. And if you were to do cosine 360, you would find that it's 1, and cosine 0, it's 1 as well. So it goes from 1 to -1 and passes here at 90 degrees. At 180, we've got -1, and at 270, cuts it here. So what you notice now is when I had 0 degree, at 90 degrees for the cosine, because it's a complementary, the complement of sine, I get exactly the same value. So I need to be at 90 degrees to have the 0. Okay. And that means if we've done our work correctly, because 45 degrees is halfway between the two, 0 and 90, and 45 plus 45 give me 90. If you check sine 45 and cosine 45, they'll be exactly the same value. So cosine 45 is equal to sine 45. So now for the key features, you would pretty much say the same thing. I've got this time cos 0 degrees start at 1. My roots this times are 90 for x and 0 for y. That's what we call roots. 270 for x and 0 for y. And a max this time happen at when x equals 0, y equal 1. And the min when x equal 180, I've got -1. So that's why you were asked basically to write down y equal cos x. And we've drawn both the cosine and the sine signal. And again, if we were asked to draw cosine, I don't know, of 5 cosine x, I would just change the 1 into a 5. The period is something else that is important to add. So a period here is 360 degree. And we've got a same period. It just means it repeats itself every 360 degree. Again, t for the period is 360 degree. Okay, so those are the first two that you usually would get a trig equation with, that you could use drawing your or sketching your graph and being able to find out some of the solution. So now tan is a bit more complicated. I'm sure I've seen that when I was looking at your graph. But if you were to draw tan x basically is just sine x divided by cosine x. That's what tan x is. The tangent of x is just sine x divided by cosine x. So that means when sine x is 0, you will get tan x equals 0. So you will start at 0 and you will find out your period this time, instead of being 360, if you look through Desmos, you would notice that tan x start at 0, then grow and just comes and never crosses that line. That line there never crosses it. And then at 180, again, you've got a similar type of graph. And that's what tan x is. And it repeats itself every 180 degree. So at 90 degree, we've got what we call asymptotes, like line that never get touched. Because you can't divide by 0, remember, cos 90 is 0. So because we can't divide by 0, you would never get a value for tan 90. So it repeats itself, and again does exactly the same thing here. And then it would just go up that way to 270 here. And then at 360, it would come back up and just touch 360. Okay, so that's tan x, but it's not something that is asked during a nat5 exam, draw tan x. No, I've never seen that. It's always either sine or cos, but it's good to know what it looks like. Okay, so key features, this time the period t, as you can see, is 180 degree. It doesn't have a max, it doesn't have a mean. You do have roots. If someone asks you what are the roots, they'll be the same as the roots that you have for sine. So 0, 0, 180, 0. And then you can keep going 360, 0 if you're asked to find them. Okay, so no mean, no max, a period of 180. So that was your homework basically to do 1, 2, 3 graphs. Okay, any question on that? All right. So what you will find is, if you remember, you had a circle. So a circle with a radius of 1. So this is how you should remember what we've just done. Y represent the sine axis. Y is the sine axis. Okay, Y represents sine and X represent cosine. So when you were doing SOHCAHTOA, if your hypotenuse is equal to 1, remember, so opposite, sine is opposite of a hypotenuse. So the opposite side of this angle is this side here. And if your hypotenuse is equal to 1, basically sine of your angle So if I'm asking you to find sine for this angle, and this is a half, yeah? So if this is a half here, 0.5, you'll find out that this angle is 30 degrees. So sine 30 is a half, and cos 60 is a half as well. Because remember what we said, the complement of 30 is 60. So cos 60 is equal to sine 30 degrees. And now, if someone asks you to divide a pizza in 6 or 12 equal portions, probably very rare that you would do that. Let's say you were asked to cut a massive cake in 12 equal sections, just like my gran used to do, because her dad was a baker. He used to find half of the half, and he used to put a wee dent with the knife there. The other half, we dent there, and he would do the same on that side, a wee dent with his knife on each side, and everyone was happy that we had equal portions. So she was doing trig without really understanding what we were doing. So she could just cut perfectly a cake in 12 portions by just halving the half, which is why cos 60 is 0.5 and sine 30 is 0.5. So next time you want to impress your friends, you could show them how you can cut a pizza in equal portion and no one will be jealous, would like to have the bigger portions. Okay? Who thinks that's a bit geeky? No one saying no? There you go. I bet you love people would know how to cut these, but without understanding the math behind it. Okay? Any questions, guys, before we move on to the next past paper question? No? Yes?
No.
No? Is that complicated, what I've just done?
I mean, I probably won't remember it, to be honest.
So what I've done is just, if you take a circle, right? And you half it, okay?
Mhm.
If you know where the center is of your circle, or you've got an idea where it is, so if you half that again, and you just go up, that means you find 60 degrees, a precise 60 degree. Okay, so that angle 60 here shows me that cos 60 is equal to 0.5. That's where it's coming from.
So when would we need to use that in nat5? Or would we need to use that in nat5? Or is it just kind of good to know?
It's good to know. So, because I bet you one day you might have children asking you to cut something in equal part, because you can half a half, right? And you can put wee dent there, and then you will get a perfect 1, 2, 3, 4, 5, 6 portions. No? So you don't have to know this by heart, because if you type in your calculator cos 60, you will get a half. But if you were to go and do higher math, then you would need to know these by heart. But I never learned these by heart because I remember this piece of cake, how to cut it. Okay. So it's just a trick of the trade. All right, so let me show you a past paper question so that you have an idea what kind of question you could get asked with regard to trig graph. Okay, so in this past paper question, which was given back in 2018, so paper one is a non-calculator paper. This would be 2 marks. I've been asked to identify A and to, again, find the value of B, which means I need to replace this A with a value and this B with a value. So everyone should get A. See, at least you should score half of the mark here before I'm going to go and talk to the B's. So A is what we call the amplitude. Okay. To find the amplitude, you look how tall is your graph. It goes from 5 to -5. So that is 10 units, right? And you just half it. So 10 units divided by 2, that's your amplitude. This is even easier because it's a perfect, basically, cosine graph between a maximum and a minimum. So A is just that value here. So amplitude A equal 5 by just looking at my graph. Okay. Now, how do I find B? That number here, B, would tell me how many times this signal here, the cos signal, repeats itself within 360. Okay. So how many times do you think it repeats itself within 360? I've got here 2 times within 180. So if it repeats itself twice within 180, how many times do you think, how many of these would I have if I do 360? How many of the cos? 1, 2. So just imagine if this was just going on, it would be 3, and then it would be another one up to 360. That
So
is the
before.
Yeah, so that's the B. That's how you find B. You imagine if you had 360, how many of the same pattern do I have within 360? And then you can just write B equal 4. And that's you scored 2 out of 2. Now you might ask me, is there another way to find B? Yes, there is, because basically B is what we call, if you've got 360 degree, you divide that by B, you get the period. So what is my period here? The signal repeats itself after how many degree? 90. What do you need to divide 360 by to get 90? Which is exactly what I just said here. How many times does it repeat itself to make 360? 36 divided by what? Give me 9. 4. And that's you've got B that way as well. So B, you could, without having to draw it, you can find out that B, that means B equal 4. Because your period is 90 degree. But if you couldn't remember this formula, because remember, I would rather remember something, how many times does it repeat itself within 360? To me, that's easier to remember than having to remember, oh, I need to do 360 divided by B and write what the period is. So you see that, to me, that has got more to remember than trying to see how many times can I fit it within 360. So it's up to you. Some of you might be good at remembering formulas. Some of you may say, do you know what? I think if someone tells me sine 2x, I just put 2 of the sine wave within 360, which means the period is, instead of 360, 180. Here, when you've got 90, b equal 4. Any question with that? But again, you need a bit of practice if you do them. And that's why we were saying, if you start drawing the first one, like you were asked to do during your homework, you have an idea what the graph looks like. So everyone would know now that the sines start at 0, 0, whereas the cos start usually up or down, depending on which way, but it goes and start going down and back up again. So that's what the cos does. Whereas sine would start at 0 and just keep climbing. Okay. Are you a bit better informed now? So the equation y equal a cos bx is going to be y equal 5 cos 4x. And we've drawn here 5 cos 4x between 0 and 180. That's what they gave us. I've added it between 0 and 360 if you want to. And remember, you won't have like square papers. That's why I just said to you, it's good to be able to just sketch it. All right. So as an adder, what you'll find is we have other transformations. So sometime the graph will get moved up or down. So I will add a couple of lessons that help you to move the graph up and down in the y direction, or it would be stretch on the x direction. And when we do that, we get what we call a shift. So we get a shift in phase here. So I think the value here is 45. So this graph here has been shifted by 45 degrees. Okay. And because I normally start at the top here for cos, it's been shifted by 45. Because it's got shifted to the right, we need to take away 45. So when you shift to the right, you just write y equal cos of x minus 45 by how much has been shifted. If it was shifted to the left, so if instead of starting here, I had that there, again by 45, it would be plus 45. Okay, so there's a couple of lessons that will come and show you how to figure this out. So this is what we call a change in the phase. The phase is just the angle, so the angle has been changed. It just means when I've got x equal 45, 45 minus 45 would be 0, which is what cos is going to be here. So that one here is at 45 degrees rather than being at 0 when there's no shift in the phase. Now, when it comes to shifting in the y direction, normally sines start at 0. If your 0 has been shifted to here, the value of plus 2, then instead of writing y equal sine x, you just say y is 2 plus sine x, because we've added 2 to our sine x. So if you were to do like, I don't know, if for example, you were working in a place where they play with sound, they could shift the volume up by just increasing a static value onto the wave that is created, and that would give you more power to your sound, for example. So they can change the amplitude, but they can shift it up and down as well. And if you wanted as well to change the frequency where it starts, you just change the angle. So sometimes it's written 2 plus sine x, or you see it written as sine x plus 2 as well. It's the same thing, right? But this time you need to do this when you write sine x so that it's separated. So sine x plus 2. Okay. Whereas here, it's the angle that's been shifted. So you will get an extra lesson for that to be able to see what they mean. There are some exercises on Leki, I think 24E and 24F or something. And they relate to that extra lesson. Okay, so 23D, E, and F, those transformations can be combined, and there are some problem solving. So I doubt during the nat5 exam, you will have something as complicated as that. I think because they know how tough it's been with COVID, people missing lessons and etc. They're not going to make, question that complicated. But if you wanted to pursue or do more with the trig, or even understand how it works, then you can see vertical transformations and horizontal transformation. Okay. So I'll have them before the end of the week. Any question? Yeah, so we use it everywhere. Whatever you do, you will use math. I can tell you that, but most of the time we don't really understand. So this week's work, you're going to be working with trig equations, solving simple trig equations. For example, if someone asks you, what is cos x? When do you have cos x equal a half? So that could be a trig equation. Then you would remember how you draw cos. You would put back again your x-axis and your y-axis, and you would say cos x is a half because this is 1. This must be here when I get a half. But as you keep going, you can see that you've got 2 solutions. And now, because you've practiced that and you know what your graph looks like, if you're asked to solve this between 0 and 360 degree, I expect you to come up with 2 answers. So there'll be technique shown to you how to find those 2 answers. Okay. The first one is to find the inverse of cos. You just use your calculator and put cos minus 1. So shift cos gives you cos minus 1. So that means your first value is x equal cos minus 1. So inverse cos, and you just put a half. And now you can tell me, if someone's done that, you can tell me what value you got for x. And if it's correct, it's going to be linked to that cake I was telling you about. So if you do inverse cos, what do you get? Cos minus 1 over half. I don't have my calculator here, so that's why I'm asking someone to do it in the group. So you do shift cos and put 0.5 if you want, close bracket. What is the answer?
I'm just trying to do it just now, sorry, 2 seconds. I don't have my calculator either.
Or do you have NCalc FX? You can use that.
I'm just trying to use my phone just now, 2 seconds.
So there is an app called NCalc FX, which is exactly the same as the Casio. So if you've got that app, and you open it, you do shift cos, and that should come up with cos minus 1 like this, open bracket. And then you can put either the fraction or 0.5. So Andrew came back with an answer. Yeah, 60 degrees. So if you do that, you should get 60 degree, which ties up exactly what I was telling you about earlier on. So I've got 60 degree that way. So x equals 60 is one solution. But again, remember from 360, I should have a similar value, but 60 degree before 60. So what is 60 degree before 60? So that is one solution. The other solution would be 360 minus 60 degree, looking at my graph, and that is 300. Yeah. Now, if you type cos 300, remember I told you about math? Whatever you find, plug it back in, and you should get cos 60 equal a half, and then cos 300. So check cos 60. Hopefully you got a half, and then cos 300. Let me know what you get.
I did cos 300 and I got a half. Yeah.
There you go. So we've got two answers, and we've just checked them. And if this was the question asked to you during an exam, not only you remembered your graph, you kind of knew that you needed two answers for this to work. The first one, you just use your calculator, but the second one, you can't find it with your calculator. You will be shown something called a cast diagram. So if someone remember having done nat5, where you had C, A, S, T, and we said A means all my angles are positive here. So that was the first one. And because we've got C for cos here, the next solution is 360 minus alpha. And that's what we got here. So you'd be told this, that means you don't need to remember the graph really. If you know cast, you should be able to find the two answers. But the good thing about knowing about the graph is now you've got a visual representation of what's happening in real life. Cast is another technique where you need to kind of learn by heart again. Where are all my signal positive in this quadrant? Sine is positive in this quadrant. And it's true. If you remember, sine is positive in the first and the second quadrant. So that's why you put S here. Cos is positive in the first quadrant and in the last quadrant. And that's why we got C here. So all those techniques, you'll be able to see them as you go through this process. Okay. So any questions for today's lesson?
Adrian, I was going to ask if it was possible if you could send me this PowerPoint so I can look through it, because I really struggled with trig stuff when I was doing National 5 Maths back at high school. So it'd be good to just have it on hand just in case.
Okay, so you want the animated PowerPoint plus this slides that we went through today, I take it, yeah?
Yeah, if that's okay.
Yeah,
Thank
that's
you.
fine. So if someone else wants a PowerPoint, I've got some PowerPoints that I used to teach face-to-face that are animated. So if you think that would be beneficial, let me know. I can add them actually in the Canvas as an extra file that you can pull from Canvas as well. Just let me know.
Adrian, see for the mini prelim,
Yep.
are we going to get like a list of like all the topics, or is it just going to be
So yeah, mini prelim will be everything from unit 1 and unit 2 that you've done so far.
Right, okay.
Okay, and I think when it comes to the final exam, SQA, I know in England anyway, for the GCSE, they've put a list of things that are going to be touched during the exam. Okay, so we might have something very similar for nat5, but they tend to do that quite late in the day because they still want the teachers to teach the full curriculum. Okay, there's no point me teaching you 3/4 of the curriculum, especially for those who still wants to do more math. Okay. I know you may say, oh, but if we got taught less, we might, have less to know. But it doesn't really work like that. Usually what you'll find is as you go through, you will make link, especially the last topic, the last unit. It's basically it's application. It's very much what you've done in unit 1 and unit 2 applied to some real life type scenarios. Okay. Any questions?
Nope.
All right. I think that's us for today.
Thank you.
We've made it within the hour, which is not too bad. And hopefully you'll be able to cut your pizza now in exactly 6 portions without having anyone moaning that they've got the small part.
Thank you.